Okay, Chem 7, welcome back to this happens to be the third video in the series of the supercritical review for the Common Exam, which comes up on May 13th. All right, so this is going to finish the section on electron configuration. This is all stuff that we've done before, but I'm hitting the highlights of those things. So the last thing that we need to talk about before I move on to other review topics is how you take electron configurations to identify number one elements and then write the compound they would form if they reacted. So if we look at this electron configuration here first, this is neon. Again, this is a shorthand notation, and then what follows it is the valence of 3s2. So the only element that could correspond to would be magnesium, because neon has 10 electrons. The valence here has 2 additional, and that's a total of 12. So this has to be magnesium. All right, in the other situation, we have helium that is providing 2 electrons. This is the core, actually. These are core electrons. And then you see the valence here is 2s2, 2p4, a grand total of 6. So this element is out of group 6a. So 6 plus 2 is 8. So this one has to be oxygen. Now, when these two things ionize, right, the Mg is going to go to Mg plus 2, and the oxygen is going to go to O minus 2. So when these guys form a compound, the compound is going to be MgO. MgO. All right, now moving over here to this other example. Again, argon is the marker for this one, so to speak. All right, it precedes the element. There's a total of 18 electrons here. And then we have this valence, which is 4s1. The grand total is 19. So the candidate for this is going to be potassium. Total of 19 electrons. So it has to have also 19 protons. All right, the next option here, again, this is neon, and there's a total of 10 electrons being contributed by it, and it's going to precede whatever this element is. And then you can see here's the valence, 3s2, 3p5, 5 and 2 is 7, so this is out of group 7a. And since we're in period 3, it has to be chlorine. But also we know it's chlorine because there's 7 electrons here, 10 coming in off the neon. That's a grand total of 17, and that's the atomic number of chlorine. So we're going to write this down. All right, now K is out of group 1a, so when it ionizes, it's going to be K+. And the Cl is out of group 7a, so when it ionizes, it's going to be Cl minus 1. So these two guys are going to combine to form the following compound, KCl. All right. So if I was you, I would practice various combinations of these things. First, write the electron configuration using the shorthand notation, identifying the element, and then putting together, the compound that they're going to form. All right, and with that, I'm going to go ahead and conclude the video.